Understanding sequence notation. So far, we have shown some of the first terms of a sequence to help you in identifying the pattern. However, this method, known as the list method of representing sequences, is not very helpful when we want to find terms of a given sequence that are far from the first terms. Therefore, we often use algebra to show a sequence and its pattern, as this helps generalize the approach. In this case, we say to have used the sequence notation to provide information about a given sequence. Thus, we denote any term of a sequence by a letter, usually X, Y, U or A, and a number as an index, usually starting from 1, but sometimes the index starts from 0, however, here we will start from 1, to show the number of term in a sequence. We express the general term of a sequence by the index n. Hence, x, n indicates the general term, the nth term, of a sequence, x, 1 indicates the first term of a sequence, x27 the 27th term of that sequence, and so on. The pattern of a sequence is given by using the sequence notation too. For example, the mathematical sentence, we have the following shown on screen. Indicates that any term of the given sequence is obtained by multiplying the previous term by 3 and subtracting 2 from the result. Thus, if x1 equals 6 and the 8th term of the sequence described is required, we have the following shown on screen. As you see, the sequence notation allows us to find as many terms as we want in a sequence, even if the terms are big numbers. In addition, you don't have to care about identifying the pattern, as it is already given. Another advantage of the sequence notation is that one can easily process the info provided in this form using computer systems. Example: the first term of a number sequence is -3 and its general term is x, n equals 11 minus 2, x, n minus 1. Find the fifth term of this sequence. Solution: using the procedure described in theory, we obtain the following shown on screen. As you see, the sequence notation helps in dealing with sets of numbers that at a first glance do not have anything in common with number sequences. In other words, if we didn't have the general term of the sequence given, it would be very difficult to spot any pattern in the set of values -3, 17, -23, 57, -103. That is all for lesson 12.1.3. To continue this tutorial, please watch 12.1.4, a fast method for finding the nth term of a sequence. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.